There are four forces acting on an aircraft. They are defined as follows: thrust, drag, lift, and weight. Thrust: the forward force produced by the power plant, propeller, or rotor. It opposes or overcomes the force of drag. As a general rule, it acts parallel to the longitudinal axis. Drag: a rearward force, retarding force caused by disruption of airflow by the wing, rotor, fuselage, and other protruding objects. Drag opposes thrust and acts rearward parallel to the relative wind. Weight: the combined load of the aircraft itself, the crew, the fuel, and the cargo or baggage. Weight pulls the aircraft downward force because of the force of gravity. It opposes lift and acts vertically downward through the aircraft's center of gravity. Lift: upward force opposes the downward force of weight, is produced by the dynamic effect of the air acting on the airfoil and acts perpendicular to the flight path through the center of lift. An aircraft is free to rotate around three axes that are perpendicular to each other and intersect at each center of gravity. The lateral axis passes through an aircraft from wingtip to wingtip. Rotation about this axis is called pitch. Pitch changes the vertical direction that the aircraft's nose is pointing. The elevators are the primary control surfaces for pitch. The longitudinal axis passes through the aircraft from nose to tail. Rotation about this axis is called roll. Rolling motion changes the orientation of the aircraft's wings with respect to the downward force of gravity. The pilot changes bank angle by increasing the lift on one wing and decreasing it on the other. This differential lift causes bank rotation around the longitudinal axis. The vertical axis passes through an aircraft from top to bottom. Rotation about this axis is called yaw. Yaw changes the direction the aircraft's nose is pointing, left or right. The primary control of yaw is with the rudder. Ailerons also have a secondary effect on yaw. It is important to note that these axes move with the aircraft and change relative to the earth as the aircraft moves. The pilot flies the airplane by making control adjustments that rotate the airplane around three axes. These axes move about a single point called the center of gravity. The pilot can pitch the airplane up or down, veer it left or right, and roll the wings from side to side. The airplane's orientation relative to the Earth's horizon is called the attitude. The yaw is defined as the attitude relative to the aeroplane's flight path, not the horizon, so when the pilot refers to the airplane's attitude, generally, they only refer to the position of the nose and wings relative to the horizon. For example, when an airplane pitches up, this is a nose-up attitude. When the airplane rolls to one side, this is a bank attitude. It's worth noting that the attitude does not directly translate to the direction of flight, as this depends on other factors such as airplane's airspeed. For example, nose-up attitude may suggest that the airplane is climbing, but at lower airspeed, the same attitude may suggest that the airplane is in level, or airplane is in a stalled state. Lift is the upward force on a plane. Various parts of a plane help to achieve lift, but most of the lift is created by the wings. The magnitude of lift depends on the shape, size, and velocity. For example, the faster the plane goes, the greater the lift. The lift that is produced by the wings must be greater than the weight of plane to leave the ground. What factors affect lift? The size and the shape of the wing, the angle at which it meets the oncoming air, the speed at which it makes through the air, even the density of the air, all affect the amount of lift a wing creates. The importance for crew members to be alert for abnormal aircraft functioning is to demonstrate effective verbal, non-verbal, and written communications, to demonstrate effective teamwork and leadership, to detect errors and traps them before they produce negative consequences. Cabin crew members must immediately recognize an abnormal or emergency situation, rapidly gain awareness of situational dynamics, if necessary, initiate communication with the flight crew or take the necessary measures to deal with the situation. Informing the flight crew of abnormal situations observed in the cabin or relating to the aircraft, such as pressurization problems, engine anomalies, and contamination of critical surfaces.